Hey friends, welcome to my channel, and in this video I am going to discuss about a very important problem. It is a stereoselectivity problem, the stereoselectivity of the aldol reaction, and it came in CSIR exam December 2012. I already discussed some of the stereoselective aldol condensation reactions. You can check out that, but this is somewhat different from that. And before watching this problem, you should have the knowledge of Zimmerman fractional model and the stereoselective aldol condensation. So in the previous videos where I discussed the stereoselectivity in aldol condensation, I already told that the aldol condensation reaction goes through a cyclic chair-like intermediate or transition state, and in that case we don't have any stereocenter in our starting material. For example, we had only a simple aldehyde and a simple enolate. Now in your enolate there may be some stereochemistry. For example, your enolate may be cis or trans, so only stereochemistry was there in your enolate part, but there was no stereochemistry in your carbonyl compound. But you can see in this problem which is given here, there is a stereo center in this aldehyde also. So whenever this stereo center comes, the outcome of different products increases, and that means in this case you should get more product. Now, how to predict the stereoselectivity of this particular reaction? So first, so in this case the question was given like this. They gave you this aldehyde and plus something B which is giving this product, and now they gave B as this one. So they basically gave this one as B, and either it may be this E alkene or E enolate, or they gave this Z enolate also. So these options they given, and with this they gave the combination like which phase will undergo the attack. So they give the combination Re-C, Re, and your C, and your this type of combinations they give. With this combination they give you 4 options, and you have to predict which is the right answer. Now this is not the only way that how they can ask this question. They can give you this question also. They will not give you the product, they just give you this particular starting material, and with this they can give you this one. So this aldehyde this ketone they can give, and with this they can give you the LDA. Now which give A, and now reaction of A and this compound will give you product, so you have to predict which will be the product. So in this way the question may also come, or they can give you the enolate, and then this aldehyde may be missing, and you have to tell which aldehyde is there. So these many combinations are possible for this question. Now what is more important is that when you are drawing the Zimmerman fractional model for this particular type of particular compound, you have to careful about one thing, that while I discussed the Felkinen model, there I told you that in the Felkinen model you have this type of conformation. Let's say this is your aldehyde, so in this case this is your aldehyde, and you can have this type of combination. Hello. So this is the conformation which will undergo the reaction. Okay, so in this case you have to take into account this factor. For example, let me draw the transition state of the Zimmerman fractional model, but before that I want to do the nomenclature of these centers. So in this case you can see this is A, this is B, and this is C. So hydrogen is D, which is which is far from us. So this is A, B, C. This is anti-clockwise, that means it has S configuration. Okay, so this S configuration should be maintained throughout the reaction. Now let us draw the Zimmerman fractional model. So this is your lithium. So in this case the enolate. So one thing before drawing the Zimmerman fractional model, one thing I should discuss is that you have given this ketone, and it is treated with LDA first. So now while you treat a ketone with LDA, what will be the geometry of your enolate? So it can have 2 geometry. Either it may be this Z, or it may be E. Okay, so this is E and this is Z. Now whether it will be E or Z, that is dependent on this group, and in this case you can see this is a bulky tert butyl group. So due to the presence of this bulky tert butyl group, this methyl group and this tert butyl group will try to stay as far apart as possible. So in this case Z conformation will be preferred, but if it were a methyl or ethyl group, then this E conformation would be preferred. So we know that we had our Z alkene in our hand. So in the options, if where E alkene, E enolate is given, we can easily discard that, and we will then left out only with two possibilities, which are Z. Now we have to predict from which phase the attack will occur. So now let us draw the Zimmerman-Traxler model. So we can have two Zimmerman-Traxler model. One is where your lithium is there, and now you can see this is your aldehyde. So here it will be your aldehyde, and here it is your enolate partner. So you can see this is your enolate. Now your enolate, there is your tert butyl group, and I already told that it will be your Z enolate. So your methyl group will be here, and this is how the interaction will take place. So basically it will look like this. Okay, so I can draw it like this. Okay, now it look like a chair form. So this is how it will look like. Now this stereo center you have to draw very carefully. So in this case you can see this has S configuration. So now we can place. So while we discussed about the Felkinal model, we told you that whenever you have some electronegative substituent or conjugating group, that will be always perpendicular to the carbonyl group. So let's say this is the Newman projection formula of the same compound, and now your phenyl group will either be like this, or your phenyl group will be like this. So these two possibilities are there. Now that means your phenyl group may be like this, or your phenyl group may be like this. Now what will be the position of the phenyl group, that you have to choose very carefully. You can see if the phenyl group has this configuration, you can see both are it is not perfectly eclipsed, but you can see both are in the same direction. So there may be steric hindrance, so it will avoid this type of configuration, and that's why phenyl will adopt a position here. Okay, so phenyl will be here. Now your rest of the two groups, that is your methyl group and the hydrogen group, so you have to place them carefully. Now you can see you have to place these two groups such that it will have S configuration. Now how to draw that? So this is your A, this phenyl is your B, and another group will be C and D. So now you can see if you rotate it like this, A, B, C. So if you rotate it like this, you can see it is an anti-clockwise rotation when your methyl is here and hydrogen is here. Now you can see hydrogen is far from you. You are looking from this side, so it is now your A, B, C. That means it is your S configuration. So it is anti-clockwise, so S configuration. So this is the right configuration of the molecule. Now what can be the other way of or other possibility of the Zimmerman-Traxler model? So basically other possibility means you can see the two phases of this carbonyl group is not equal, because so now you can see if the board is the plane of your aldehyde, then it has two possibility of attack. Either the enolate can attack from this side, or the enolate can attack from behind the board. Now this particular Zimmerman-Traxler model shows that the enolate is attacking from behind the board. Now another possibility is that this is your lithium, and in this case you have to draw the aldehyde this side and your enolate this side. So this is another possibility, and now you can see, okay, so this is your group. So now these have the same configuration because it will be S here. So this is your phenyl, and this is your hydrogen, this is your methyl. Okay, Now here you have the tert-butyl group and here you have the methyl group. So these are the two different possible orientation or transition state which can be obtained from these two combinations. Now you have to decide which way the reaction is favored. So if you look at this particular center here and here, you can see that in this case, while the enolate is attacking on the carbonyl group, the phase is already blocked by this methyl group, whereas in this case in the attacking phase there is hydrogen group. So you know hydrogen has very less steric units. You can say that there is no group at all. So obviously this mode of attack will be favored, and out of that you will get this product. So here you will have the tert-butyl group, here you will have the new keto will form here, and now you will have the methyl group here. This is your one hydrogen, this group. Now here another stereocenter is produced. This is your OH. Okay, so now here you have the phenyl, here you have the methyl, and here you have the hydrogen, and here you have another hydrogen. So this is the most possible product, this is the preferred product. So this is product A, and out of that you will get another you will get the different product, and in this case the product is, you can see, this is your phenyl group, this is your hydrogen, this is your methyl, here you will have another stereocenter OH, and this is your H. Now in this case you can see this is your methyl, this is your hydrogen, and here the carbonyl group is reproduced. So these two products are possible. Now you have to match these two products with this, and obviously in the question they gave you the major product because this is the major product. So now we can verify this. So this is A, it is already confirmed. Now you have to do the nomenclature for this center. So you can see in this case we can do, this is A, and this will be, this side will be your B, and this side will be your C. So in this case you can see this is A, B, C. This is like anti-clockwise, but hydrogen is in your side, so that means anti-clockwise hydrogen is in your side, so that means it will have R configuration. And in this case you can see, in this case you can again do, this is your A, and this is your B, this is your C. So in this case hydrogen is again in your side, and you are doing like A, B, C, so it is now clockwise. So if hydrogen is in your side and it is clockwise, then it should be S. Now you can do the same nomenclature here. You can see this is your A, this is your B, and this is your C. So this A, B, C, this is anti-clockwise rotation, but hydrogen is away from you. So this is your S configuration. Anti-clockwise means S. In this case it is A, and it is B, and in this case it is C. So it is, you can see A, B, C. It is a clockwise rotation, and hydrogen is away from you. So it is R. And in this center you can see, in this case this is actually A, this is B, and this is C. So again you can see A, B, C, anti-clockwise rotation, and hydrogen is away from you, so it will be S. So these two perfectly match. You can, so in this case you can do the configuration in the same way, but I am not doing because it is not our desired product. So this is how you have to first analyze which is the product. Now you have to determine the phase of attack. So in this case you can see this is your alkene. Okay, so I am drawing it again. So in this case your aldehyde is like this. This is your R group, this is your hydrogen group. Now this is your A, this is your B, and this is your C. So A, B, C, it is clockwise manner, so it is rephase. So the above phase is rephase, and the below phase will automatically be C phase. Now the attack is occurring from the below phase. You can see attack is occurring from the below phase, or attack is occurring on the below phase. So as the attack is occurring on the below phase, that means the C phase of your aldehyde is undergoing the attack. Now what is the case for your enolate? So this is your enolate, you can see this is your enolate, and in this case also this is A, this is B, and this is your hydrogen, this is C, this is actually methyl. So in this case you can see A, B, C, it is now clockwise rotation. Okay, so it is clockwise rotation, means it is rephase, and in this case the above phase is rephase and the below phase is C phase, like same way, but in this case the attack is occurring from the above phase, and that's why the rephase of your enolate is doing the attack. So the answer of this question will be, so you have 4 options in your question, and the right option according to set A will be option 3, where it is given the attack is Re-C, and it is your Z alkene. Okay, so this is the correct answer of this question. Now I will give you one exercise out of this question, that the same enolate is given, but in this case you have given, so in the previous case you were given this aldehyde, right? But now try the same reaction with this aldehyde. Okay, so now it was your S configuration, but in this case you can see this will be your R configuration. So you try by yourself that what will be the product when you use the R aldehyde, and you should practice this, because if you don't practice it, there is a high probability that you can do mistake in your exam. So I hope I am able to explain this thing to you, and if you like this video, then share it and give thumbs up. And also, if you are new in this channel, subscribe my channel, visit my website. Plenty of study materials will be soon available there. So thank you for watching.